This module covers the aircraft's electrical system, from sources and distribution of power to the operation of the system from a pilot's perspective. Normally, electrical power is supplied to the aircraft by engine-driven generators on numbers 1 and 4 engines. Electrical power on this aircraft is delivered through an automatic busbar system, which is made up of AC busbars and DC busbars. AC is converted into DC through transformer rectifier units. In addition, an APU generator or an external AC power supply can be used. External DC power can be used for engine starting. In this module we will cover the following, which you should read before continuing. On completion of this topic, you will be able to identify the following. Under normal conditions, number 1 generator supplies AC power to AC bus 1. Number 4 generator does the same for AC bus 2. AC bus 1 and AC bus 2 are normally separated. However, they may be connected by an autobus tie system. This allows a single generator to power both AC busbars. AC bus 1 powers the essential AC busbar, which then supplies the emergency AC busbar. The AC1 essential and emergency AC busbar system is known as AC channel 1. AC bus 2 forms AC channel 2. AC channel 1 supplies the captain's flight instruments. Within AC channel 1, the essential AC bus supplies the captain's primary flight instruments. The emergency AC bus supplies the standby flight instruments, which are located on the captain's side. AC channel 2 supplies the first officer's instruments. A third AC generator is fitted to the APU. The APU generator can provide power for both channels on the ground. However, the generator can only supply a single channel in the air because of cooling limitations. Priority is always given to channel 1 if both engine-driven generators fail. If only the APU generator is available in flight, why is priority automatically given to supplying power to AC channel 1 only? External AC power can also be used to supply the electrical busbar system. The supply of power to the bus bars is controlled by contactors. Through the automatic operation of the contactors, if two power sources are available within the aircraft, one will be used to supply each channel. If only a single source is available, this can be used to power both channels. The exception to this is the APU generator, when it is being used in the air. The contactors are interlocked to make sure that no more than one AC power source can connect to a single bus bar at any time. DC power. We have now covered sources and distribution of AC power. We will now look at DC power. DC power is normally supplied by two transformer rectifiers, which are powered by the AC bus bars. AC bus 1 supplies TR1, which supplies 28 volts DC to DC bus 1. AC bus 2 powers TR2, which provides 28 volts DC to DC bus 2. DC bus 1 feeds the emergency DC bus bar, which then feeds the essential DC bus bar. The four DC bus bars are normally connected to form a single bus bar, which is supplied in parallel from both TRs. If a TR fails, the remaining TR can supply all the DC bus bars. According to customer specification, either one or two 24-volt batteries may be fitted to the aircraft. In this module, we will be dealing with a two-battery configuration. When the aircraft batteries are selected on, they are connected to the emergency DC bus bar. If the batteries are the only power source, the contactors to the other DC bus bars will remain open to prevent the batteries being overloaded. Standby power supplies. That completes our look at DC power. So, having looked at normal sources and distribution of electrical power, we will move on to standby electrical power supplies. If the normal sources of power fail, a hydraulically driven standby generator can supply essential AC and DC power. The essential bus bars then supply the emergency bus bars. The standby generator operates automatically if power is lost to AC bus 1 and AC bus 2, provided that its control switch is set to arm and the green hydraulic system is fully pressurized. If the standby generator is not available, and provided the standby inverter control switch is set to arm and the batteries are switched on, the standby inverter draws power from the emergency DC busbar to supply AC power to the emergency AC busbar. Battery power is automatically converted to AC power and then supplied to the captain's standby instruments. This completes our review of the aircraft electrical system. The next topic will look at the components in more detail. On completion of this topic, you will be able to describe the following. Each engine generator supplies 115 volts three-phase AC power at a constant frequency of 400 Hz and has a continuous power rating of 40 kVA. A constant speed drive unit maintains the constant frequency output throughout the engine power range, from idle to maximum power. The engine generators are cooled by their individual lubricating oil systems, the oil being cooled by fan bypass air. The temperature of the oil system is monitored, and if it overheats, a warning is given. If overheating reaches a critical limit, the generator is automatically and permanently disconnected from the busbar system. The APU generator is identical to the engine-driven generators, except that it does not require a constant speed unit, because the APU itself is running at a constant speed. The APU generator does not have a separate cooling system. It is cooled by the APU turbine oil, which passes through a heat exchanger in the APU compartment. The APU cooling system is less efficient than the engine generator cooling system, and as a result, there are restrictions on the use of the APU generator in flight. If the APU oil becomes too hot, it will shut itself down. Each generator has its own generator control unit, which has two main functions. These are to control the output voltage and to protect against faults. The fault protection circuits monitor voltage, frequency and current. And will disconnect the generator from the busbar system if a fault is detected. External AC. We have now covered the generators and generator control units. Next, we will look at external AC in more detail. An external AC power supply can be used to supply electrical services on the ground as an alternative to the APU. The external AC source must be 115-200 volts, 3-phase 400 Hz constant frequency, with a power rating of at least 60 kVA or 40 kVA if engine starting is not required. Three-phase AC power supplies can provide a voltage of 115 volts, measured between a phase and earth. Or 200 volts measured between phases. When specifying a three-phase supply, both voltages are usually referred to for the same power supply. On this aircraft, we can only measure the phase-to-earth voltage on the flight deck. The measurement should read 115 volts. The quality of the external AC supply is checked by the ground power monitor unit when the power line is plugged in at the ground connection panel. A green light will show the engineer that the supply is acceptable and can now be selected inside the aircraft. The indication is repeated on the cabin attendants panel and shows that AC power can be connected to the aircraft for cabin lighting and cleaning. The indication is also shown on the overhead electrics panel. Although the annunciators will remain lit all the time the AC power supply remains within the specification, you still need to check the quality of the supply before selecting external AC. If you have any doubts about the external supply, you should not attempt to make a connection. The contactors. We have looked at the sources of AC power. We will now look at how sources are selected. The AC busbar system uses 5 contactors which control the connection of AC power sources to the busbars. The contactor system will automatically try to connect the engine-driven generators to the busbar system as a preference. If only the engine-driven generators are available, the contactors will automatically select each engine generator as the reserve power supply for the other channel. If a generator then fails, the contactors will automatically use the remaining engine generator to power both channels. If the APU generator or external AC power is available, the contactors will automatically select this as the reserve power supply. If a generator then fails, the contactors will automatically try to use the APU generator or external AC power. Which generators are capable of supplying both AC bus 1 and AC bus 2? Transformer rectifiers. The contactors connect the various sources of AC power to the AC busbar system. Transformer rectifiers are used to convert AC power to DC power for the DC busbar system. The transformer rectifiers are connected to the AC busbars by contactors, which are remotely controlled by circuit breakers on the overhead panel. What is the function of the TRs? The TRs are connected to the DC busbars by automatic cutouts, which close when the TRs are operating normally. The aircraft batteries. AC power is converted to DC power via the TRs. The aircraft batteries are another source of DC power. The aircraft batteries are connected to the emergency DC busbar by individually switched battery contactors. In addition, battery number 1 has a permanent connection to the battery busbar. This is called the hot busbar, and it supplies power to certain vital services. Battery voltage must be 23 volts or more before the DC busbars are energized. A lower voltage than this could result in an overcharging of the batteries, as no limiting device is fitted. Battery charging is carried out by energizing the DC busbars from the TRs. Charging is indicated by the battery voltage, which goes up to 28 volts, and the ammeter, which is showing a charge. If the batteries are overcharged, they will heat up and could explode. This extreme situation is prevented by an automatic disconnect of the battery. On completion of this topic, you will be able to describe the following. The standby generator supplies 115-volt three-phase AC power at a constant frequency of 400 Hz. It can also supply 28 volts DC via an internal transformer rectifier unit. Where is the standby hydraulic generator powered from? The standby generator is driven by the green hydraulic system. In order to generate the correct output, it requires the full system pressure of 3,100 psi. To ensure that this pressure is available, the green hydraulic services will be isolated. The loss of pressure to the services is indicated by the low pressure warning. Full system pressure is still displayed on the gauge. A generator control unit ensures that the voltage and frequency are correct before the standby generator is connected to the essential AC and DC busbars. If a fault is detected, the standby generator will be disconnected from the busbar system. Standby inverter. If the standby generator is lost, the standby inverter is ready to maintain power to the emergency AC busbar. The standby inverter is an electronic device and requires no mechanical drive or cooling. It converts battery power to 115 volts AC at a constant frequency of 400 Hz, which is then supplied to the emergency AC bus. When two batteries are installed, the standby inverter will supply power for approximately 60 minutes. If only a single battery is installed, this is reduced to approximately 30 minutes. Battery life will depend on the electrical load, which can be reduced by reference to the checklists. These are the electrical system limitations. Load shedding may be necessary to remain within these limits. If, during flight operations, a system failure is accompanied by a circuit breaker operation, one attempt may be made to reset the circuit breaker if a reset is specified in the relevant emergency or abnormal procedure, or the system is operationally essential. On completion of this section, you will be able to carry out the external checks associated with the electrical systems and be able to identify problems which require further investigation. The Electrics pre-flight walk-round check involves checking the electrical equipment bay. Before checking the electrics bay, check that an external AC ground power supply is connected and switched on, or that the external AC panel is closed. Check that the DC ground power connector door is closed. The electrical equipment bay door is on the right of the aircraft. Click on the bay door to continue. Inside the electrical equipment bay, check the condition of the batteries. They should be securely mounted and there should be no fluid leaks. Check that all of the aircraft circuit breakers are set. Check that the wheel spin test switch is set to the normal position. Check that all equipment in the bay is secure. Having completed the checks within the bay, check that the access door is closed. Should you find a problem with any of the components you have checked, call an engineer. Initial checks describes the checks needed to make the aircraft safe before electrical power is applied. Before we apply electrical power to the aircraft, we need to make sure that nothing dangerous is going to happen. First, check that the gear lever is down. Make sure that the radar and transponder are both set to standby. Accidental transmissions by these devices can be harmful to anyone standing close to the antennas. Then check that the flaps lever agrees with the flap position noted on the walk-round check. Finally, make sure that all circuit breakers are set. We now look at applying power to the aircraft. Flight Deck Safety Checks describes the checks carried out prior to engine start. On completion of this topic, you'll be able to The first step in powering up the aircraft's electrical system is to turn on the battery master switches. Turn on the battery master switches. Operating the switches closes the battery contactors. DC power is now applied to the emergency DC bus bar and through the standby inverter to the emergency AC bus bar. The annunciators also show that we have no power on AC1, AC2, or the essential AC bus bars. Why is the emergency AC off annunciator extinguished if we only have battery power available? We check the batteries by using the DC voltmeter rotary selector switch. Set the switch to battery 1. The DC voltmeter rotary selector switch is now in position. Read the voltage on the DC voltmeter. The minimum acceptable reading is 23 volts. For readings below 23 volts, the batteries must be changed. The battery no charge indicators will come on a short time after selecting the batteries on because they are discharging. The ammeter also shows that the batteries are discharging. We also need to repeat the procedure for battery 2. And then set the selector switch to off. If an aircraft is left for too long with the switch to either battery position, it is possible to drain the battery if it's not being recharged. The next action is to check that the AC bus tie switch and the DC bus tie switch are both set to auto. What is the purpose of the AC bus tie system? We now check that the standby inverter switch is to arm. The emergency AC annunciator is out, and that yellow brake pressure is indicated at this power level. Next, we check that the standby generator switch is to arm. We have armed the standby generator. Why isn't it working yet? The next action is to check that the engine generator switches are to off reset. Finally, we check that the APU generator switch is to on. The aircraft is now at the emergency power level. In flight, these are the electrical instruments you would still have available. the standby attitude indicator, the captain's attention getters, some of the MWS warnings, the EGT gauges, the N2 gauges, the yellow brake pressure gauge, the number 1 needle and DME of the captain's distance and bearing indicator, the captain's VHF navigation and DME control panel. Although the standby altimeter is not an electrical instrument, it is also available at the emergency power level. If external AC power is available, then you can connect it to the busbar system. The flight deck annunciator shows the pilots that AC power is available. The aircraft ground power monitor will check the quality of the external power source, but the pilots also need to check it before connecting external AC to the busbars. Use the volts frequency rotary selector switch to do this now. If the supply is in limits, then external AC can be selected on. Observe when you turn the switch on that the switch returns to the central position. Select external AC to on. Now that the system is powered up, all the warning lights have extinguished. If the external supply goes out of limits for any reason, it will disconnect. The external supply will then have to be replaced with an alternative power supply. As an alternative to external power, we can use the APU generator to supply the busbar system before we start the engines. Your choice of using external or APU power may be forced by company policy or airport regulations. Starting the APU will be covered in the APU module. We will assume that the APU has reached governed speed and that APU power is available. The APU generator will automatically connect to the busbar system. This is because we have previously selected it on. Note that you have not checked the quality of the APU generator output before it was connected to the busbar system. What has happened to external AC power? The APU has taken over from external AC power, and this can be seen on the ammeter. At this point, we disconnect the external supply. Select External AC to off. External AC can now be removed from the aircraft. Normal management takes you through management of the system from engine start through to shutdown. On completion of this topic, you'll be able to. Because engine starting is the subject of another lesson, we will assume that all engines have started, and now we need to bring the engine generators online to power the busbars. The generators are being driven, but there is no indication of power output. Why is this? The function of the off reset position is to clear any faults detected by the GCU. The function of the offline position is to check the quality of the generator output before connecting to the busbar system. Put generator 1 to the offline position. Now check the generator output on the AC meters. Check the output from generator 1. If the supply is acceptable, then we bring the generator online. Bring the generator online. We repeat the actions for generator 4. Look at the distribution of power now. Generators 1 and 4 are sharing the load. The APU has no load. Although the APU generator is not supplying the bus bars, it remains connected in a reserve power mode. Depending on your airline policy or local performance considerations, the APU may be left on for takeoff and then shut down at some stage in the climb checks. When the APU is shut down, the APU generator offline annunciator does not come on because there is no power to the generator. This light should only come on when the APU is running and the generator is not connected. The APU is restarted on the approach or on the ground depending on company policy. The APU generator control switch is still selected on, and so the generator will automatically connect as a reserve to the busbar system. Before turning off any engine generators on the ground, we need to make sure that the APU generator is available. Check that the APU generator is available. We must also check that the flaps are not moving when we start switching power supplies. A power interruption could cause a flap fault. When we are satisfied, we turn off the engine generators. Switch the number 1 generator to off reset. We now turn off the number 4 generator, so that the APU generator is supplying all electrical power. Once parked, we can connect up external AC. The quality must then be checked before external AC can be selected on. Check the quality of external AC. If the quality is acceptable, then external AC is selected on. You need to note that the switch returns to the central position. Select external AC to on. No indication is given that external power is connected and waiting in reserve. When we shut down the APU, external AC will automatically connect to the bus bars. After completion of the shutdown checks, we can switch off external AC, followed by the batteries. Set the switches to off. If power is needed in the cabin, external AC can be selected on at the cabin attendant's panel. Engine starting looks at changes made to the electrical system to support engine starting. On completion of this topic, you'll be able to We will now look at the requirements of the electrical system for engine starting. Each engine is fitted with a DC starter motor, which is supplied from the DC start bus. The preference for powering the DC start bus is firstly AC power converted to DC power through the TRs, then external DC power, and then the aircraft batteries. If the aircraft has to be pushed back from the stand during engine start, the APU generator would be used. If the APU is used, then APU air must be off to reduce the load on the unit. Where available, external AC would be used if the aircraft was stationary for engine starting. To cope with the demands of starting, the external AC supply must be rated at a minimum of 60 kVA. If both external AC and the APU are unavailable, or if a TR is unserviceable, an external DC supply can be used. The external DC source must be 28 volts rated at 2000 amps. Battery power can be used for starting if two batteries have been fitted and the aircraft has been modified for a battery start. In this case, battery power would be used to start engines 1 or 4. The engine generators should then be used to cross-start the remaining engines. The N2 of the relevant engine must be at least 60% before we try to start the other engines. As a last resort, we can leave either engine 1 or 4 running during a turnaround, so that its generator can be used to provide start power. This is a potentially very hazardous procedure for ground personnel and should only be used if no other sources of power are available. That covers the choices of power supplies for starting. We will now look at the configuration of the system. The current required during start is so large that it cannot be supplied by a single TR. When AC power is used for starting, both TRs have to be serviceable. The TRs in turn must be powered by a single source. To ensure a balanced flow through the TRs. If two power sources are available, the starter motor can be damaged. This would be caused by the change in load on the starter as one power source fails and the other takes over. It is therefore the crew's responsibility to check that only one source is connected to the aircraft before engine starting. The electrical system is automatically configured so that only one power source is connected to the busbar system during engine starts. This is achieved when the Start master switch is selected on. When the starter bus bar is powered, the white Start Power On light will illuminate. The engine starting procedures will be covered elsewhere. Here is the aircraft in flight with the system set up as you would normally expect to see it. Both engine generators are operating. The batteries are selected on and the APU is shut down. What would be our first backup if a generator was to fail? Let us assume that engine generator number 4 develops a fault. The GCU will disconnect the generator from the busbar and the first thing you will see is the amber Generator 4 offline annunciator coming on. Look at the number 1 generator ammeter. The entire busbar system is now being supplied by this generator. To reduce the load on the generator, electrical power to the galley has been shed. We can attempt to reinstate the lost generator by first checking that the AC selector switch is set to the engine 4 generator position, and then setting the control switch to off reset. Set the control switch to off reset. The generator is completely shut down and reset in an attempt to clear any faults. Now check the output of the generator. If the output is acceptable, the generator can be brought online. If not, set the control switch to off reset. Take the correct action. The fault on the generator has not cleared. Although the aircraft can be safely operated with a single generator, we do not have full backup in case of further loss. What additional power source can we use at this stage? As the APU reaches governed speed, the green APU Power Available caption lights, and the APU generator is automatically connected to the busbars. Look at the schematic. The number 1 generator is supplying AC channel 1. The APU generator is supplying AC channel 2 and will act as the reserve supply for AC channel 1. Dual generator operation has now been restored and both generators are sharing the load. Partial galley services have been restored and no other services are lost. The aircraft is now being supplied by the number 1 generator and the APU generator because the number 4 generator is offline. Let us assume that a fault is now detected on number 1 generator, which is then shut down by its GCU. The number 1 generator has failed. What do you think will happen next? The APU generator will switch from channel 2 to channel 1 in order to maintain power to the captain's flight instruments. We can try to reinstate the number 1 generator, but in this case, we will leave it shut down. We have now lost an AC busbar. Set the control switch to off, reset. At this stage, we lose the first officer's instruments, although the captain's instruments remain fully powered. The APU is supplying AC channel 1 only, but TR1 is powering all the DC busbars. Let us now suppose that the APU generator develops a fault and is shut down. The APU generator offline caption has lit. The remaining bus bar fail lights have come on, as we have no electrical supplies to AC bus 1 and TR1 cannot power the DC bus bars. Provided that the green hydraulic system is functioning normally, the loss of AC bus 1 and AC bus 2 will have started the standby generator. And the standby generator on annunciator will have come on. The essential and emergency AC and DC off annunciators will remain out as the bus bars are powered by the standby generator. What other annunciators are now lit? Click on the new annunciators. To reduce the load on the standby generator, the batteries are disconnected from the bus bars. This can be seen by the zero flow on the battery ammeter and the battery voltage falling to its nominal 24 volts. All generators should be set to off reset position. No further attempt to connect the generators is allowed. An unsuccessful attempt could affect the operation of the standby generator. The APU generator cannot be used, so we shut the APU down. This saves fuel and also battery power. The aircraft is now at the essential power level. All of the captain's instruments and all of the engine instruments are still powered. Let us suppose that the standby generator fails. When the essential AC bus bar failed, the battery contactors closed, supplying power to the emergency DC bus bar. The emergency DC bus then supplied power to the standby inverter to power the emergency AC bus. There is no direct indication of failure other than the standby generator on light going out and the essential AC off and essential DC off annunciators lighting. More importantly, the captain's primary instruments will be lost. At the emergency power level, these are the instruments which are still working. The standby attitude indicator, the captain's attention getters, some of the MWS warnings, the EGT gauges, the N2 gauges, the yellow brake pressure gauge, the number 1 needle and DME of the captain's distance and bearing indicator, the captain's VHF navigation and DME control panel, standby altimeter. How long can we continue to fly on emergency power if the aircraft has 2 batteries fitted? As we have reached the emergency power level, we can now attempt to reinstate a generator, starting with the standby generator. Set the standby generator switch from arm to off. The green hydraulic system must be fully pressurized. Note that at the emergency power level, the hydraulic warnings and indications are not powered. Therefore, the only way to ensure that the system is fully pressurized is to set the number 3 engine to at least 70% N2. Now select the standby generator switch to override. If this is successful, the electrical system is back to the essential power level. Set the standby generator switch to override. If reinstating the standby generator fails, its switch is put to off. And an attempt would be made to regain the engine generators. Even if we cannot restore any of the generators, the aircraft is still capable of making a safe approach and landing in IMC.